Good morning, good afternoon, or good evening. This is Mr. Parks. I want to go ahead and do a quick video for homework help for 6th grade for lesson 1.1 for Go Math. In 4th grade, we introduced long division, and over the last couple years, we've asked students to do more and more difficult things with long division. For instance, last year we asked students to work with slightly bigger numbers for our dividend, which is our starting number. For our math problem, that is this one right here. We've also asked them to work with larger divisors than we have in the past. We also introduced dividing with decimals, which we may need for a problem later. I'm going to try to work something in to practice that before we finish this video. So one of the new types of questions that's brand new for this year that they haven't done in the past is this. So here's an example from our lesson. Find the greatest whole number that can replace the square to make this statement true. So we need a number that is less than our quotient for this problem. All right, so let's find this quotient. So most of my students, if I ask them, can you skip count by 47s? They're going to say, no, of course not. That's silly. And I can't probably count by 47s either. If I sit here and think about it for a few moments, I can go one number at a time. But really what I'm doing is I'm starting a list that looks like this. So I'm going to put a little 1 out to the side. And then to find the next number, I'm going to do 47 plus 47. And I would think about that for a moment. That's going to, I believe, give us 94. And then I would say that this is my second number. And then I'm going to do this one more time. We're going to end up lucking out on this one and not need to go any further than this. But here's our first 3 numbers. And this is the strategy that I ask students to use when they need to find our math facts for counting by numbers that are larger than the math facts that we currently have memorized. It's perfectly fine to do this. Just be very careful that the work is being done correctly. So let's talk through this problem. Our first problem, or step of the problem, shall we say, if I ask my students to teach this up on the board or when I'm talking to them, I am going to ask them, how many times does 47 go into 51? Okay, they're really close together. If we make a list, we can find out the answer as well. This is going to be 1. So we're going to write that up top. Next, we need to multiply the number we wrote on top times our divisor. So 1 times 47 is 47. Our third step is to subtract. Our answer for that will be 4. I'm just going to go ahead and quickly show the borrowing part that I would ask students to do. And we are going to bring down this digit to create the number 47. And we're going to go back to step 1. So how many times does 47 go into 47? Just the one time. We get the same math fact that we used earlier with the same numbers together. Our subtraction problem is going to equal 0. We bring down a 1. And now we get to a part that stumps some 5th and 6th graders and 4th graders when they're first learning division. How many times does 47 go into 1? Most of the time I'm going to have hands shoot up right away and say, Mr. Parks, that doesn't work. You can't make 47 go into 1. And you're right. You cannot. However, there's a number that we use to represent how many times that will work. Since it doesn't work, that number is a 0. So we're going to put a 0 up top. We would multiply, get 0, and we are going to have a remainder of 1. And we're going to talk about remainders and how they turn into fractions to help with another part of our problem in just a moment. So we need our box to be a number that is smaller than 110. So the largest whole number that will work before 110 is 109. So 109 would be the answer for that problem from our lesson. So one problem will be pretty much exactly like that. There's one where they're going to ask a number that fits between two different math problems, although I might skip that one in the interest of time. All right, so I'm going to move my screen over just a little bit, and then I'm going to show you another problem that more closely resembles what I was just talking about. So we'll do some easier numbers. Let's do 6 as our divisor, and let's do 51 as our dividend, our starting number. So practicing what I talked about before, if I don't know how to count by sixes, or whatever number we're working with, I would ask students to write out their math facts. And so I'm going to go all the way through that while I go ahead and start talking through this part over here. So we would start with seeing how many times 6 goes into 5. Since our answer for that would be 0, and we don't have a decimal, we're going to group both of these together to do how many times does 6 go into 51. And so in just a few moments, I am going to have the first 10 math facts written out for 6 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. So 8 times 6 is going to give us 48. We can use that. Plug in the 8 for our quotient. We have our multiplication answer here if we did our work correctly. And when we subtract, we would get 3. Again, I ask students to show this step for borrowing when we subtract, just to make sure that everything has happened and we don't just accidentally end up off by a value of 10 in our answer because we forgot to take away here to borrow. So we have a remainder. Right now, if we want to write the answer with a remainder, our answer would be 8 remainder 3. When we get to the last digit of our dividend, whatever we have left over becomes either a remainder, in this case, the remainder of 3, or it becomes part of a fraction. So let's rewrite this out to the side so we can take another look. Once we do this, we are going to end up with 3 left over. And so the part where students occasionally get a little bit thrown off, the 3 is going to be the numerator. This is going to be the top number of our fraction. The divisor is going to be the denominator. So our answer would start as 8 3/6. And then I would ask the students to go double check, can we have 3 go into 6? And since the answer is yes, what we need to do to finish reducing is to actually do 3 divided by 3 equals 1. 6 divided by 3 equals 2. And our final answer, once we put that back in with our original problem, our fraction would be 8 1/2. Actually, it would be a mixed number to use the correct term. But the fraction part that we're reducing is going to change into 1/2. All right, so there's a couple ideas to work through the division questions that they're going to ask. One additional thing before I stop, I'm just going to slide this down. We have a couple problems working with decimals, and we're multiplying. And we haven't done that yet this year. So let's go ahead. I'm just going to do a very simple example. And let's treat it like this. Okay, so here's our math problem. We have to keep track of these decimals. So we're going to multiply. We're going to start with 2 times 1 is 2, 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2. Not going to do anything with the decimals yet. We have one more row to go. We're going to start that second row with a 0. 1 times 1 is 1, 1 times 3 is 3, 1 times 2 is 2, and 1 times 1 is 1. Again, we're working with this digit here the second time through. I'm going to slide this up just a touch. And we're going to add our two numbers together, two rows. And when we do that, we are going to end up with this number here. And our final step is to work in our decimal points. So what I ask the students to do is to go ahead and count over one place like this until we get to the decimal. So our first one, we're going to move over one spot, and then we need to do the same thing for this part. So our decimal is going to move in 1, 2, 3 places. It's going to go here. And to say that number, it would be 14 and 762 thousandths. Okay? So we're going to treat the multiplication part just like we would any multi-digit number for both the top and the bottom, and treat it like that type of multiplication. Again, something we've practiced since 4th grade. The part with the decimals we only started learning last year in 5th grade, and so here's kind of a little refresher. There's one that's going to work similar to what I just did on the board here, and there's going to be one that's 3 digits on top, or maybe 4 digits on top, times a single digit on the bottom. And so you only have to keep track possibly of one place worth of numbers for the decimal point on that, or keep track of one set of numbers for the decimal point, I guess is a better way to say that. So I hope this helps. Hope you guys are successful with this. I'm going to try to do more of these since I'm only teaching 5th and 6th grade math, and since we aren't doing homework every single day, I'm going to try to do a few more of these to try to get you ready in case you need the help when the homework assignment goes home. Have a great day, and we will see you next time.